Hey, thank you. Again, in the back, good? Awesome, thanks. So today I'm going to go through some thought process around building a customer quality dashboard. This is how I usually think through this problem when I want to track any kind of metric. So what I'm going to show is, I will show a dashboard which is an example of what I've built in the past. But more importantly, I think, is the thought process on how I went about doing this. So sound fair? Good. If you want to ask any questions, just raise your hand. I will try to answer questions in real time, because I think that's good. We have the context. Alrighty, so why do we do metrics? Because we want to look for the right things in the right place. Alrighty, and before I get started, I just want to tell you a little story. There was one time in my life when I wanted to drop a few pounds. I know, if you can believe that, that was true. And what I did was, now this was before we had apps and a lot of personal technology, I went out and bought a book. And the book was Lose Weight by Eating a Low-Fat Diet. And what the methodology in this book said is, if you consume fewer than 20% of your daily caloric intake, if fewer than 20% of your daily intake comes from fat, that's a low-fat diet and you'll lose weight. Okay, good. So what I did was, I had a little notebook, I kept it in my pocket, and I recorded everything that I ate that day. And then the book also had a nice friendly lookup table in the back. That was probably 3/4 of the book was a lookup table. So you look up, oh, I had chicken breast and it has so much protein, or it just had calories and calories that came from fat. So at the end of the day, what I was doing was I would add all the math up. Now it's okay, I had all these calories during the day, and here how many calories came from fat, did the math, and every night, 22, 21%. I was just over the deadline. And I went, oh man, I know how to fix this. And so usually what I did was, I got 2 beers and a bowl of pretzels. So I had about 500 fat-free calories. I always met my goal. Now, I didn't meet the ultimate goal of losing weight. And I keep thinking about this every time, this experience, every time it comes to tracking things and measuring things. I'm always asking, are we measuring the right thing? Is this measure affecting the true bottom line? Are we really focused on the right priorities? And is this measure bringing us to those right priorities? So I'm going to go through how the methodology that I use now in place to hopefully measure things that are more relevant to the goals that we actually have. And before I do that, I'm going to just step through a few principles that I like to apply to metrics. So first is your metrics have to be relevant to your goals. So there's a great website I love spending time. It's called Spurious Correlations. And this shows that the murder rate in the US is very tightly correlated to the market share of Internet Explorer. Sorry, all you Microsoft guys out here. Next is you want to provide relevant information. Now the friendly folks of Gold Hill, Colorado, that town was established in 1859. It has an elevation of 8,400 feet and a population of 118. So they very kindly did the math for us to tell us that's just over 10,000. Next, you may want to think about, do you want a leading indicator or a lagging indicator? So obviously I hope this is good news for them. And you want to use the right technology to display your metrics. So this is actually Nadia Comaneci. In the 1972 Olympics, she was the first person to ever score a perfect 10. Now, the 72 Olympics were in Munich. I can't believe the German engineers didn't design the scoreboard to be able to show 10.0, so they had to use 1.0 to represent her score of 10. Alrighty, one last. You need to provide actionable insights, so your data should inform what you want to do next. Okay, so now the meat is the goal, question, metric paradigm. How many have heard of this? Okay, great. So looks like about a third of the room. So the other 2/3, I'm very glad I came here. This is a very cool methodology for designing your metrics. Now the GQM was, or initialized GQM, goal, question, metric, was created by Victor Basili from the University of Maryland, and he was also doing this work with NASA, so you know it's really good if it came from NASA. But we learned something today about NASA, didn't we? It's all about math and meetings about math. So the goal, question, metric methodology starts off with aligning with a set of goals. And this is where you want to work with your stakeholders, your partners, the developers, the PMs, your bosses, everybody, to establish what are your goals. And usually we do this. We do this like on an annual basis, or maybe every quarter we update our goals. Then you ask questions about those goals. This is the Q in GQM. And then after that, you design and collect metrics to answer those questions. So GQM, goal, question, metric, you align on a set of goals, you ask questions about those goals, and then you design your metrics to answer those questions. Got it? Make sense? Cool. So why do we do this? One, setting goals with alignment with a wider organization gains acceptance. I don't know, how many times have you started tracking something, quality metric, some type of metric, and then you get immediately into an argument about why this? You know, why are we tracking this? With the GQM method, you have your first conversation is about the goals. So the rest of it is all about relating your metrics to those goals, so you can draw that line of sight to the rest of the team. This helps you focus what's most important to your stakeholders. They're going to invest a lot of time and energy into helping you establish your goals, and so you want to be able to measure those, and you have alignment with your, I keep saying alignment, but this helps focus your activities on what's important to your stakeholders. Provide line of sight from your metrics to your goals. Again, often you'll get in arguments about why this is a good metric or not. This helps you answer that question or avoid the question. And what I like best is it provides a comprehensive view of your goals. So just like the example story that I started off with, I was only tracking one thing, which is just a small component of the overall health goal. It was the percentage of calories that came from fat. If I had used this methodology, I probably would have understood better. It's total caloric intake and minus outgoing, and built a more comprehensive view of what I was eating. Okay, let me go through an example. So provide some context. So let's say we have a software as a service application, and this has many, many, many active users. They pay a monthly subscription, so you know they don't want to come into work, turn on their browser, log into your system, and go, oh crap, it's not working. So it needs to be constantly working. And in this case, if you have functional bugs escaping to your customers, that's not a good thing. So I want to go through the example. So let's say we set a goal of delivering better quality as measured by fewer defects to your customers. Sound like a good goal? We probably already, all of us have the same exact goal, I bet. So here's just some questions that came off the top of my mind as I started to think about this. One is, how many defects do our customers actually report? Okay. How are we trending on the customer reported defects? Is the trend line growing? Is it shrinking? About the same? How quickly do we fix these defects? If our customer reports a problem, is it open for a long time, or do we fix them relatively quickly? And what are the top causes of these problems? So we definitely want to learn about each problem that our customers report. And then we also want to understand, how did it escape? Or how are these problems escaping? And how come we're not catching them? So here's a dashboard that I built to answer these questions. Now, I'll explain what this is, and I will make these slides, I think, are available for download. Have you guys seen them? Okay, so that's existence proof that they are available for download. Thank you. And you're looking at it now. Awesome. In the upper left is my favorite widget from Jira. It's called the recently created widget. Anybody familiar with this? Yes, you guys are lucky. I love it. What this shows is two dimensions. The number of issues is along the y-axis, and time is the x-axis. Now what I've done is, for this one, set it up to look for a year and look at data by month. So this gives me a full year worth of customer defects, and the filter is filtering just on the customer reported issues. The color is, okay, so wait, in this month, most of these months, the customers reported 20, and you can see it spiked up to about 30. Well, that's, excuse me, about 10. And it spiked up to about 30 one month. So that's what the data means, is the height of the column represents the number of bugs in that filter. In this case, it's customer reported issues. And the color is the status. If they're green, it's fixed. If they're red, they're still open. So this one gives us a pretty good visual snapshot for several of those questions. One is, how many bugs are the customers reporting? Well, it's averaging about 10 a month or so. It's relatively flat, so we have a couple of spikes. We have some data. The way this works is it captures data as of the date that you run the report. So I had just a few days in that month on the beginning and a few days on the previous month. And it kind of gives us a little indication of how quickly we're fixing the bugs. You know, we see we've got one outlier here, and a couple ones that are maybe 3 months old. But for the most part, we're fixing them within, about a month, it looks like, for most of the bugs. And what I like to call this chart, it's called the recently created widget in Jira. I like to call it the Yoda chart, because you want it to be short and green. Short meaning few customer bugs, green meaning they're fixed. Next is the average age graph. And so what this shows is, again, how quickly are we fixing them. This shows the average age of the open bugs. And I'm going to talk to this graph in a minute. I don't really like it, but I included it here to be complete. Next is an root cause analysis Pareto. So one of the things we do when we have customer issues, we do a root cause analysis, we document that in Jira, and then we have a little drop down that we have the categories of these problems. So that allows us then to build a graph and sort it by most frequently occurring, and that's a Pareto graph. So we have coding errors and missing requirements are the top two reasons for these problems escaping. And the reasons for escape, missing test case, data configuration, environment, etc. So we always ask those two questions. Actually, we ask three questions when we do the root cause analysis. One is, what was the actual problem, the actual root cause of it? Second is, how did it escape all of our testing and checks? And third is, what are we doing differently? So those are the three questions we ask. So we have those answers in Jira when we fix these issues, and it's very easy to create a a graph of those categories. So this is the dashboard that answers the majority of those questions. Any questions here? Cool, good. I'm sorry, what was your? Oh, for this one, it's called the recently created widget in Jira. It's a built-in, and you can apply it to any filter you want. In this one, I applied it to customer found defects. This was fast. We got done very quickly. No, we're not done yet. All right, so here's some things to think about as you do this yourself. So one is process metrics versus outcomes. So I want to give you an example. If we were trying to measure how good we are at code review, a couple of thoughts on metrics. One could be, let's look at the lines of code reviewed per hour. We did this in one company I worked, and what we found was the good reviews had kind of a sweet spot on how quickly we were reviewing the code. If we were, some of the reviews said they reviewed 2,000 lines of code in an hour. And that just didn't feel like we actually did a good job reviewing that code. Versus we had some where we spent a whole hour and reviewed maybe 50 lines of code. That didn't really seem like we were being productive in that session either. So we kind of had a sweet spot on between like 200 and 500 lines of code per hour. So what we were doing though was we were measuring the process of the code review. Now another metric you could use is the number of defects found per review, and maybe you do that by severity level or something. And that is another indicator of how good you or how effective your reviews are. Now one is a process metric. You're measuring the inputs in the process that you're doing, and the other is the outcomes. Can you see that distinction? Cool. We had that funny picture about leading indicators and lagging indicators. Give you another example or a real world example. Code coverage. So if you're measuring code coverage of your tests, that's probably a leading indicator that you may be delivering better quality. I know there's some skepticism on the code coverage as a metric, but my guess is there's going to be some correlation between code coverage and delivered quality, especially it gives you some information before you do the release. Rather than the delivered quality, which is all about what I was showing earlier, these are all lagging indicators. They're telling you about how you've done in the past. So you want to think about, do you want to make some leading indicators? Lagging indicators have the benefit of, they're actually true. So it's hard to argue with the data. Versus leading indicators have some predictive value. Okay, what do you show if you want to aggregate data? So median versus average, or better yet, percentiles. So median page load time versus the average page load. So if you're doing performance testing, often the tools will punch out an average page load time. And I was just looking at some data the other day. The average page load time, it was response time for a REST call. Was about 6 seconds, and that seemed pretty slow. But when I went in and looked at the data, the median page load time was actually about 150 milliseconds. There were 2 or 3 calls that took like 18 to 20 seconds. So those two outliers skewed the average and kind of painted not a great picture. Looking at the raw data actually helped us go diagnose to figure out what was happening. So if we wanted to evaluate our systems, usually with performance, I look at like the median response time or median page load time. But even better, I like to look at the 95th percentile or 99th percentile response time, because that tells you that the vast majority of your responses are coming within that value. So it's much easier to communicate to your stakeholders, hey, we've got a problem, because 95% of our users takes 5 seconds for the page load for 95% of our users. That's an easy conversation to have. Talking in terms of averages and standard deviations, that's a little bit more difficult to have that conversation with your stakeholders. And another data point on averages. The average income in San Mateo County in 2012 grew by 38%. Man, I want to move to San Mateo County. That's awesome. Can anybody guess what happened in 2012 in San Mateo County? Facebook went public. So Mark Zuckerberg brought the average up by 38%. So averages actually hide some interesting information. So that's why I like to look at either the median or percentiles. Okay, another is direct measures instead of derived measures. One example is AppDex, which is kind of a industry standard measure for performance. That has a lot of acceptance, so people understand what that means. But I've tried to use like quality scores in the past, where what these things do is they average up, or that you apply some formula. Like I remember one, we had each critical defect had a weight of like 20. Each major defect had a weight of 10, 5, and 1 for the trivials. And then we would do this math and add it up and say our quality score is 96. Well, every time I did that, I ended up having to explain what the data meant, and actually had to click down and show what the underlying data. Yeah, there was a 96 minor problems versus 3 criticals. Having these aggregate scores tends to hide some data, so I always try to avoid those. Actionable. So as we saw in the stoplight example, we want to be able to take action with our data. So give you an example, total crashes versus a crash code Pareto chart. I was leading the quality team for a mobile app, and we were crashing about 600,000 times a month. We had a huge active user base, so but that represented probably about a 95% crash-free sessions, and that just didn't feel that felt wrong to me. It felt like we were crashing too often. But just talking about hey, we have 600,000 crashes wasn't getting really the play with the team, because it just seemed to be an abstract number. But once I switched over and started talking about the Pareto view of the individual crash codes, and I just used Crashlytics, great tool that gives you all kinds of great data. What Crashlytics tells you is it says, hey, this crash code, which is in this page, is crashing 120 times a month, 120,000 times a month, and it's the top crash cause. So now we have some actionable data. Hey, let's get an engineer to go look at this crash code, look at the stack trace which is in here, and fix the problem. When we started talking about the Pareto and providing that very actionable data, we ended up bringing the crashes down by 10x. So instead of 600,000 crashes, it was about 60K crashes. And our crash-free sessions went up to like 99.8%. So taking that click down was definitely worth it. And live data is the best data. So you saw I like to use Jira, like to use the visualizations. Crashlytics is another example. What I vow I never want to do, unless my boss asks me, is to actually do the old thing where I download a bunch of data to Excel, manipulate it, make some charts, and paste them over to PowerPoint. What happens there is I end up spending a lot of time manipulating the information and data, building the story, which is all that, the building the story part's good. But as soon as you get to the meeting, the first question becomes, well, what about this? And you haven't prepared that in your slides. So what I like to do now is whenever I do quality reviews is we look at the live dashboard, which allows us to click into the data and answer questions as they come up. And it saves a whole lot of time from me having to prepare the data. All right, questions? You guys are an easy audience. Thank you. I know, we're right after lunch and you had those cupcakes. So, all right, so I want to talk about some fallacies of metrics. We're doing okay on time, right? I think we have about 20 minutes remaining. One is gamification. So one of the first questions that always comes up when you talk about metrics is, hey, can somebody game that metric? And yeah, the answer is probably yes. Because people are smart and they can figure out ways around it. But just as an aside, you don't hire people that are going to game the metrics, and you don't build the incentives that they're going to benefit by having their numbers look good. You want to have a more holistic view of the people, so that helps remove some of the incentive to gamify things. But I just want to give you an example. There's a metric called testing efficiency. Anybody hear about this one? Okay. It's kind of obscure, but it's very basic. Testing efficiency is defined by, out of the total number of bugs that get reported, how many are actually fixed, or which percentage are actually fixed. So if you report 100 bugs and 80 of them get fixed, your testing efficiency is 80%. So that's that metric. Now, you can probably easily guess that that can be gamified easy if you wanted to, right? You submit a whole bunch of easy, no-brainer bugs to fix, or even worse, you may, if you see something that's kind of doubtful, you may not report it because you're not sure if it's going to get fixed. And again, that would be in an environment where somebody was being held accountable to their testing efficiency metric. I think what a better methodology is to actually look at the data and, again, bucket into categories. So this is actual data from a project that I worked. And we were worried that not too many of the bugs that we reported were being fixed. So instead of looking, hey, we're going to improve testing efficiency, what we did was instead built a pie chart with the categories. So the blue are fixed. The reds are duplicate. Yellows are cannot duplicate. The purple are won't fix because of the business decision. And last is works as designed. So what we did then is, now that we had this data, we built our bug handling guidelines and to attack each of these issues. So we had a bunch of problems that were being reported that were duplicates of others in the database. So what we did was we just sat down with the testers and we said, hey, we'd like for you to spend 3 minutes to look for the data through the bug tracking system and see if there's already a bug similar to yours or the same as yours, and update that bug instead of writing a new one. We also had to build some better searching tools for a bug database. But that action came from looking at this data. Next is cannot duplicate. We did something cool here was before we submitted the bug, we had what we called bug huddles. And that's where a tester would sit down with the developer and demonstrate the bug for him or her. And what that did was that eliminated pretty much the cannot duplicate issues, because the developers weren't reading a step-by-step procedure to reproduce. What they saw was live, here's the bug. And that actually also improved how quickly those bugs were getting fixed, because they would dispatch it right to the right developer immediately. instead of it kind of rotting around and going in through a committee. Alrighty. Yes, thank you for asking the question.
That address bugs that come in externally that could not be reproduced inside the organization?
Oh, great question. The question was, how could that have helped with bugs that came externally from customers that we would not have had that opportunity to have that conversation? And this one really didn't address that. I think in that the process for receiving customer issues and trying to diagnose them, actually what we do is we have various tiers of our support organization. So tier 1 takes the call, tier 2 answers the questions that can't be answered by tier 1, and then tier 3 has a channel into engineering. And so I think we use those tier 3 agents as proxies to the customer. So they'll try to duplicate it in their scenario, or they actually have access to the customer data. So they'll try to represent the customer in that realm. Thanks. Yes?
Your bugs that are worked as designed, is that kind of like, you know, a lot of times our business partners don't like that communication piece, like working as it's designed to work. Are
Yep.
they reporting those as bugs?
Yes, so I think the question is, the works as designed category, are the testers are reporting things that they think it should work like this, but the development team says no, the system's working as we designed it. What we did on that scenario was two things. One is I had my snarky thing, which is there's no category for a crappy design, right? But the other thing is we in QE or the developer could not close a bug as works as designed. What we did was we brought in the PM, and the product manager had to concur. So we had all three groups had to concur that it was works as designed. Yes?
What are the most, I guess, elements on a graph that you should put before the graph gets, or your display gets so busy that it's just overwhelming to look at and you don't know what's going on?
Great. Great question. The question is, how many elements on a graph should there be, just a rule of thumb, before it gets way too busy that you can't really make sense of it? I would say you look at the data, and if it looks too busy to make sense for you, try to look at a different format. So I don't have any hard guidelines, but one thing I do tend to like to use the Pareto charts, as you saw earlier, because they provide a couple of bits of information. One is the spread, the distribution or the relationship between the metrics, but it also gives you the total count, because you can see on the left.
So how many goals would you want to try and accomplish at the same time?
Just one last thought on that Pareto. You can go as far out as you want and have a long tail, or you could just cut it off at, hey, let's just look at the top 20, something like that. But how many goals would I try to accomplish? For a goal question metric?
Yeah.
You don't want to have a ton, right? Usually from goal setting, you probably want to work on 3 goals for you and your team. Having 5 goals is okay, but trying to do 20 goals for a team really means you're not really paying attention to any one. So it's always better. The phrase that we like to say is, let's focus on the critical few, which is usually about 3, and we'll take a 4th if that makes sense. And then each goal may translate into 3, 4, 5 metrics. So now you're talking, anywhere from 10 to 20 different things you're tracking. Yes, sir.
So is this graph right here representing internal, external, or both?
This particular one is internal.
Okay, so when I look at this graph, I actually see a lot. We like to, in my organization, we like to get all the different categories, because we're seeing this as nearly, 40% of the bugs logged here are considered not valid, unique bugs, which tells us a couple of things. We need better training or documentation on the product. So
Yes. Yeah, and more of a comment. The scenario that this particular graph shows is about 40% of the bugs are waste, if you will. And yeah, and this was actually a we didn't consider this a great picture. This was the before. The after, and I don't actually have the after picture, but we got it to about 80% of the bugs reported were fixed. And the other 20 were still mostly in this business decision and works in design kind of category. So we got a lot of the, I'm sorry?
how did you get there?
Well, that's what I mentioned. So for the duplicates, we did more searching. We did better communication on the cannot duplicates. And the won't fix business decision, we brought PM in to concur with those decisions. And PM would bump a lot of those back to the team and say, no, we're actually going to fix that. Cool. Thank you, guys. Alrighty, next is confirmation bias. So confirmation bias can happen when you have a preconceived notion of what the state of things are, and you look for data that supports that notion. So have a great example. We had, I was working on a project where we were in this daily stand-up where we were going through the status. We wanted to get a release out, but we were still finding about 30 bugs a day. And the release team was really anxious because, you know, the deadline to release is coming up. And one of the things we always look for as a test manager is when that incoming rate starts to slow down. That means we are finding, you know, fewer and fewer issues, and therefore it makes sense to release maybe to the next set of customers or something, because you're getting to the end of what you're doing on your testing. And that indeed, one day it did tail off and it flattened out. It went from 30 to about 4 bugs a day. The release manager got all excited, sent out this great email about how the QE team, the incoming rate's tailing down. But he forgot something. That day, Star Wars opened up, and all the testers went to go see Star Wars. So the confirmation bias is he was hoping to see the incoming rate flatten out. The actual reality was, that was Star Wars Episode 3, 2005 when that came out. The reality was, you know, we didn't have anybody testing that day. Okay, another fallacy is survivor bias. So quick show of hands, or just shout it out, what are castles made out of? Rocks, stone, bricks. Yeah, except in history, the vast majority of castles were made out of wood. But we don't have that image now because the wooden ones didn't survive the ages. The only ones that survive are the ones that were built with stone and masonry. So survivor bias is another potential fallacy that comes in when you look at metrics. An example here is looking at an open bugs by severity type of view. So this particular one has very few critical bugs, some major, some minor. If I read this, I may interpret this, hey, our quality is not bad. We don't have too many critical bugs. But the reality might be we get a lot of critical bugs coming in, but we fix them right away. So you really have to look at the overall picture and wonder if, in this particular case, when you have a filter that looks only at open bugs, you have to realize that there may be some survivor bias in your data. All right, next is vanity metrics. Many have heard of vanity metrics. Okay, a few, good. So vanity metrics don't measure things that matter. What they do, they are easily manipulated, but they make us feel good. So vanity metrics are very popular, and that phrase actually comes from the marketing world, where things like page views and click-throughs might get you excited that you're doing the right thing, but in marketing, what really matters is how many people are signing up for your service or buying your product, not how many people are viewing your page. You could drive a lot of traffic to your page, but if they're not actually doing anything. So that's where the vanity metric phrase came from. I actually showed you a vanity metric before, which was that average age of our customer bugs. Really dramatic improvement. The average age was around 400 days. It dropped down to in the 40-day range, a 10x improvement. I said, hey, I improved the average age of our customer reported defects by 10x. That's awesome. I should get a raise. But guess what? I know we had some bugs that were in that system for 7 years. And so we just closed them. And we said, after 7 years, we're not going to fix it. The average age just dropped like a rock. So all of these drops were when we closed those really old bugs. So be careful about vanity metrics. That's why instead of average age, I like to look at the percentile, or let's say the percentage of bugs that are fixed within an SLA, within, let's say, a 30-day window for customer reported issues. So it's much easier to get better results. All right, next is Hawthorne effect. And I think we have like 3 minutes, right? All right, cool. So how many have heard of the Hawthorne effect? Okay, so the Hawthorne effect comes from a factory in Hawthorne, Illinois, I believe, where some researchers came in. They wanted to do an experiment on the lighting levels and productivity. So the story goes is they increased the lighting level and productivity went up. And they went, oh, this is interesting. So obviously more light means more productivity. So then they went off to go write their paper. They brought the lights back down to where they were before, and productivity went up. And what was happening were the workers realized, hey, management cares about us. They're doing these experiments we're focused on, and you get a temporary increase in productivity. So when you do these measures, like with the crash reporting example that I gave earlier, you often get a Hawthorne effect where you get really good progress for a few months. Then you return back to normal and things can get returned back to the status quo. So what I like to do is after we met the goal and we feel comfortable, is to put some type of process wrapper around so that we keep those gains. So for the example of the crash reporting, we ended up putting a Slack notification whenever a new crash report came up. And what that does is that kept the elevation of the crash reporting up visible to everybody. So this is the end of my prepared marks. So I work at Clover. We make a point of sale platform, a lot of Android and web work. And I just wanted to say we're hiring. So if you're interested, give me a call or contact me. And I want to ask, are there any other questions? What else can I address for you? Yes, sir.
Where do you display these metrics so your team can see them?
Yeah, great. So the question is, where do I display these metrics so the team can see them? So they're all on the intranet. And what we do is we do have, in some cases, we have a status board that displays the metrics. Right now, what I'm doing is just we review these as a team in our team meetings. Yes?
Do you have upper management requesting any metrics that you think are a bad idea or misleading or whatever?
The question is, anytime does the upper management ask for metrics that are bad or misleading? Yeah, that happens. And so what I try to do is just have a conversation about, and we can use the goal question metric, hey, why are we thinking about tracking this, and how does this relate to our goals, and try to provide a more comprehensive or a better alternative. But sometimes, there's a corporate initiative and says everybody's going to track this, and sometimes you just have to say, yes, sir. Or ma'am. All righty, well, thank you guys. Thank you very much. Have a great day.